Welcome back to the lab, folks. So I've got another package in here from Zoyi. Now this here is their new LCR meter. This one in particular is the ZT-DQ02, which is not only an LCR meter, but is also an internal resistance meter. Comes in a nice soft case. Yeah, it's an interesting combination of tools, both a handheld LCR meter and internal resistance meter, and it includes an English user manual. It's all English. That's nice. And it's got 2-wire test leads here, which are just regular, a little bit above average. It's definitely a PVC installation on them. It's not silicone, but it's okay. And they got nice sharp gold-plated tips on them. That's nice. And we've got this is a special set of Kelvin leads for the internal resistance tester. So put that over here. And then we've got 4-wire leads for the LCR meter. Same basic material as the 2-wire leads. So very serviceable, very nice. And we've also got a USB cable. I would imagine that this is going to be useful for charging it, for getting files on and off, and for doing firmware upgrades. And there is this little insulator here, which just plugs in here for doing 4-wire testing, because normally these blades here all touch for insertion of components. So for doing the 4-wire testing, you want to put these in. Or if you want to go do 2-wire testing, if you really want to, you just leave that out. Alright, so here it is itself. Let's get rid of the case. It's a nice, handsome unit. Let's do the peel here. Got a nice clean screen to play with. And it's very sturdily made. It's very similar to other Zoyi instruments. The case is very similar. Got this nice dual injection molding on it. This here is kind of elastomer material. It's kind of soft. Probably take a bump or two. It's on the corners and on the edges. And the rest of it seems to be a really tough, probably ABS material. Got a nice tilting bail on it, which is fairly stable. Got it at a nice angle, about 45 degrees. A 2.8-inch color display. It has rechargeable batteries in it. You don't have to open it up to change the batteries. You've got this USB port here for charging, taking files on and off, and upgrading it. These buttons here, they have a really nice solid feel, very positive. They are rubber chiclets, but they got a really nice feel to them. Here you've got the component insertion terminals, these little blades here, so you can fit components right down into there and just push them in place, provided of course that they have leads that are good enough for that. It says here, discharge capacitors before testing. That's a really good idea, just in case you take a capacitor out of a power supply and you want to check it out and it's got like 60 volts across it. This wouldn't like that very much. And up here we've got this special connector here for the internal resistance tester. It's one of these aviation type things where you just push it into place once you get it oriented properly, and it snaps in like that. So you don't have to do anything, and then to remove it you pull the ring up and it'll pop out. Okay, so let's turn it on. Let's go in here to the setup menu. It shows the firmware version here, the language, and you can set the brightness. This is the auto off timer here, so it's set for 15 minutes, but you can set it for whatever you want. I can set the beep on or off, and you can get in here into calibration. Let me talk to you a little bit about the calibration here. In here you can calibrate for the LCR bridge, or you can calibrate for the internal impedance tester. If you go in here you can see, so you can do a short calibration and an open calibration, and generally speaking they're the only ones I would do. So if you're moving from using these terminals here to using the 4-wire, you want to do an open and short calibration, and then if you move it back again you do the open and short calibration again, just to take the resistance and the capacitance of the leads out of the equation. And it also allows you to do all these other ones here, so you can calibrate it for 10 milliohms, 100 milliohms, 1 ohm, 10 ohms, 100 ohms, 1K, 10K, 100K, 1 meg, and 10 meg. So that's an awful lot of high precision, low inductance resistors that you're going to have to need to do that. Now I did contact Zoyi on it, and they said the only time you might ever have to do any of those resistance calibrations if there's a firmware upgrade, and even then, only if you see a problem, and only do the 10 milliohm and the 100 milliohm calibrations. The rest of them should not be required. As for me, I'm just going to run with the factory calibrations, other than the open and short calibrations, which I'll do when I change my measurement type. Now, if you do go in there and start messing around with the calibration and you find that things aren't working properly anymore, go down here to factory restore and go into that. Then you can always do the factory restore here. So these buttons up along the top here, they change all your measurement parameters. So the frequency here, let's get back out of here completely. The frequency here, you can change 1 kilohertz, 10 kilohertz, 100 kilohertz, 100 hertz, 120 hertz, and we're back to 1 kilohertz again. So it's got those 6 different frequencies in there. Now if you look in here, there's a table on the bottom of page 10 that suggests what kind of frequency you should use for what kind of measurements. I'd actually read this manual cover to cover before I actually started using it. I did. You test at different frequencies for different reasons. Like if you're just generally testing a capacitor to try and characterize it, you test at the lowest frequencies to get the capacitance and the highest frequencies to get the ESR. If you have to test at a specific frequency, you can just use that. So if you're going to be using the capacitor at 10 kilohertz, test it at 10 kilohertz. If you're going to be using the capacitor, like for a filter capacitor here in North America, you want to test it at 120 hertz. Or if you're in Europe, you want to test it at 100 hertz. And that's why they have those two specific ones there too. Level changes the amplitude of the sine wave that's used to do the testing. So you can have 0.1 volts, 0.3 volts, 0.6 volts. Generally speaking, you run it at 0.6 volts, you get the best accuracy. But if you're going to be doing some testing of components in circuit, you might want to use a lower voltage there in order to not excite PN junctions and stuff like that. Now speed just really changes the update speed. So you can fast, slow, mid. Slow is going to give you better results. This button here selects what's the secondary test that you're doing. So right now we're in auto, so let's go over here. We'll go into resistance, for instance. And what you can do here is, right now we're testing for reactance, and you can change that. You can test for phase angle. You can check for series resistance, dissipation factor, and quality factor. This is kind of your mode. Most of the time, you just leave it in auto. Or if you're testing, you're testing a bunch of resistors, go over to resistance, or testing a bunch of capacitors, go into capacitance. You also have for electrolytic capacitors a special mode, and what that does here, so you see what it does, it sets the level at 0.3 volts and sets the bias at 0.5 volts. So what that'll do is, as long as you put in the plus on this side and the negative on that side, it'll keep the capacitor from getting reverse biased. It doesn't really matter that much, but it's nice to have, just in case you have a capacitor that might be particularly sensitive to that. I think we've covered all these buttons up here. Now you can also switch through these parameters down here via these arrows here. Over here we have range. Auto is where I would leave it. But if you really did want to get in there and do that, you would start off with the 100 ohms first, and then work your way up until there's a sudden change or things get unstable. And I think that's what the meter does. You just leave it on auto. It's going to do what you want it to do anyway. This oval button here sets the model. So whether it's auto selected by the meter itself, or serial, or parallel, you can select that. And here we got the hold rec button. This holds the current value, so whatever the current value is, you can hold that. Now if you give it a long press, it puts it into a mode where it will communicate with the PC, although the software is not yet available for it. Zoyi told me that it'll be coming out shortly. They're just working out the details of it. Look for that coming up on their website to be available for download. This here allows you to enter a mode where you can set up for relative tolerance tests to see if the components meet their or your specifications. If you're looking at a 1 UF capacitor and you're testing a bunch of 1 UF capacitors and you're good with a tolerance of 5%, then this will allow you to test immediately, quickly, to see if they're within that tolerance. And you can change those parameters. So you can get into here and change your capacitance of the devices you're testing and the tolerance that you're good with. I think I've gone through all the controls and everything on the thing. So let's just test some components. So what I've done here is I've got some values here that I've checked out with a more sophisticated LCR meter and a couple of batteries. So we'll just go through these ones here. And basically what I'm going to do is I'm going to have two capacitances, a bigger one, a smaller one. And the same with the resistors, same with the coils. And we'll just go through those and check them out and see how they compare to with the other meter. So it's all here. And I've gone through the configuration of it. So go through, we can do these measurements here. And here I put down the tolerance. So if we take the tolerance of this meter and the tolerance of the East tester that I used to test all these things, and you combine those tolerances, these are what we should see. So this should be within 2%, these within 3, 2, 4, and so on. So let's test these things out. This one's a 100 UF capacitor. This is the first one we'll test here. We'll put it in and see what we get here. So what I measured on the East tester was 74.3 UF. We got 74.6.7, so anywhere around there. And let's get here, we want ESR here. And the East tester measured it at 1.4 ohms. We're measuring it here about 1.3 ohms. So now let's go up to the higher frequency. And what the East tester measured here, ESR, and it measured it at 0.96 ohms. And here we're getting at 0.94. And this gives a perfect example here. So if you wanted to measure the capacitance, you want a lower frequency, Zoyi suggests 1 kilohertz. So for this range of capacitors, that's where we have it. And that's the capacitance. And then you go up to the higher frequency here and you get the internal resistance. All right, let's move on to the other capacitor. So we'll take this out and we'll put the level at 0.6. This one's got very, very delicate little leads in it. Let's see if I can get them in there. And I can. Okay. So the East tester measures this at 149.5 and we're at 152. So yeah, well within the 3%. And we'll bring it up now. 100 kilohertz, and East tester measured it also at 149.9. And again, we're right on here. Okay, so here we're in inductance mode, and I want to bring up series resistance because that's what I measured the last time with the East tester. And we're at the right frequency, correct, 10 kilohertz. And here we go. This one I measured at 903 microhenry, and we're measuring it at 895 here. So is that within the 2%? I think it's just within the 2%. And I measured the series resistance at 18.2 ohms, and here we got 18.1. So that's pretty close. This is 9 microhenry. And so I measured that at 9.00 plus or minus 4%, and we're at 9.4. And we measured it at 0.52 ohms. Okay. Let's continue on with resistors here. So we'll put this in resistance mode here. This resistor here, I tested this at 1 kilohertz. So we'll put that at 1 kilohertz. And it came out to 1.015 megohms. So let's see what we get here. And that's supposed to be 4%. We're at 1.012 megohms. And so that's really good. Now let's try a smaller resistor here. This one is nominally 10 ohms. And the same parameters there. Put that in there. Now I measured that at 9.96 ohms. And we're at 9.97. So we're supposed to be in but 0.5%, and we are. So that's fine. Okay, good. Let me try these two batteries here. Now this battery here, this 9-volt battery, I checked this out at 9.642 volts and with an internal resistance of 1.427 ohms. So let's see how close we come here. And we got 9.637. So that's very close. And internal resistance of, I measured 1.427 ohms, and it's coming up 1.447 ohms. Excellent. All right, now we're going to try this one here. This battery is a lithium ion battery, and it's the one I got. If you watch back a previous video I did, this is the one I took out of that meter and replaced because it was giving me some trouble. But let's see where we are. Where's positive? Where's okay? This is positive. This is negative. Now I measure this at 4.057 volts and 36.75 milliohms. So let's see what we get here. Okay, 4.055 and 37.24 milliohms. I want to put it back into resistance mode, and I want to try out these here. So let us do that. Let's take this off here, and we'll go into resistance mode again. Now we're going to have to put this in place. Now what I'm going to do is I'm going to do a calibration. So this will take a couple of minutes. So we'll do the short calibration first. We'll go down to calibrate, enter in there, and we'll do the short calibration. I'll speed through this. It actually takes a few seconds, like 30 or 40 seconds to do. So all right, now we're going to go over to open calibration. We'll open those leads up, and then we'll run calibration. Okay, now we get out of there, and we want resistance again. So let's try this resistor again here. This is the 1 mega ohm resistor, I believe, and we'll see how this comes out on the. And what did we test that at before? We tested it at 1 kilohertz, 0.6 volts, and it came out to 1.015, and here we got 1.006. So yeah, we're within the 4% again. And let's also try the 10 ohm resistor. And we measured that at 9.96 ohms, and we got 9.98. So that's very good. Let's even try that electrolytic capacitor too. Let's try that one as well, just for giggles. So we're going to go over here to, why don't we try it in ECAP mode, see how that compares with how we measured it before. So you have to put, you have to be careful about the polarity then. So the black goes on the negative, red goes on the positive. And how does it work in ECAP mode? Okay, so I think we're slightly higher there, not by much, and it's well within the tolerance of what we measured with the East tester. And it was at 1 kilohertz, and we bring it up to 100 kilohertz and see what we get for the ESR, which we got 0.96 ohms before. So let's bring that up to 100 kilohertz. And check ESR here. Perfect, 0.96 ohms. So, okay, so this meter checks out really well. The East tester that I tested against, it runs roughly 4 times the price of this. So I think for an inexpensive package, you're getting an awful lot of meter here. In fact, I think maybe they gave you a little bit too much, like all those calibrations in there. I think too many people are going to be tempted to go in there and play around with those and use cheap resistors and get bad results. Luckily, though, that they can actually do the factory reset and get back to somewhere normal, put in those factory calibrations back into it. And there's a lot to play around with here as far as being able to set up your measurements exactly the way you want to. So it's really good. I'm looking forward to the software coming out on it as well. So again, I encourage you to read and understand the manual. And if you don't understand what some things they're talking about in there are, ask questions. EV blog is a great place to go and ask questions like that. I've seen some people get upset online where they've gone and measured a 10 meg ohm resistor and they measure it up here at 100 kilohertz and they're wondering why they're getting a bad result. Well, it's in here. It's covered in here. They tell you what frequency you should measure things at, and they tell you where the measurements are suitable and where they're not. So yeah, so here we go here on the resistance, 10 kilohertz at 10 meg ohms. Yeah, don't test it over 1 kilohertz. It's right there in the manual, and then you won't trip yourself up and get bad results. So I think Zoyi have a real winner here. I think it's an excellent little meter for the money, and I'm going to enjoy having it around here as a backup because it agrees so well with my east tester. If my east tester does something really strange, I can always pull this out and quickly check it. And my east tester is a bench only type, so this is going to be handy for portable work. Thanks for coming out today, guys. I hope you enjoyed yourself. I hope you got something out of it, and we'll see you in the next video.